Hello everyone. Today we're going to go ahead and learn about our new chapter, which is trigonometry. And today we're going to start with introduction of trig identities. So go ahead and pause the video and graph one period of cosine and one period of sine. Okay. So hopefully you were able to see that, hey, this right here, graphing trig functions, they are from our chapter 4. So we haven't seen this in a while, but hopefully this is not something we have forgotten about. So keep in mind the increments, right? We are following the little unit circle. So remember, this is 0 degrees. This one is 90 degrees, so pi over 2. Right here we have pi, 3 pi over 2, right, at this point. And the full revolution is 2 pi. Okay, from here, these are the same numbers that we're going to go ahead and use. So pi over 2, pi, 3 pi over 2, and 2 pi. Of course, we can go on the left-hand side. This would be negative pi over 2. Just realizing that it's a reflection, so they would be negative. So negative pi over 2, 0, then pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So let's go ahead and graph it. For cosine starts at its maximum, right? Then it goes to its midline, which is y equals 0. Then at negative 1, right, our minimum, then back to the midline, then back to the maximum. Okay, and we can go ahead and continue following the same pattern to the left-hand side of my y-axis, and we can see that, hey, this is going to be this shape right here. Let me go ahead and draw it. This right here is our cosine function. Now, very important that this right here does not look like Thunderbolt. This function that is nice and continuous and curved, so it should not have sharp turns. Okay. Now, keeping in mind, another way to find is using the critical points. These are the x values of these points right here. So what is the x value here? So we have 1, 0, 0 and 1, negative 1 and 0, and 0, negative 1, just like that. So cosine are the x's and sines are the y's. So ideally, if we look at 0 degrees of y in this scenario at this point right here is 0. So this one starts at my midline. Then following this pattern, it goes to my maximum, then back to the midline, then to the minimum, then back to the midline. Okay, so we have something like this right here. So we can go ahead and connect these points right here, and we can see that this right here is our sine function. Well, at least one period of the sine function. That's why I put these little arrows to show me that, hey, this right here is continuous. Okay, awesome. So hopefully that brings back good memories of what we have learned. Okay, so let's go ahead and continue with the slides. Oops. So looking at a week at a glance, so ideally you should be expecting that we are learning this new chapter. We are learning these new lessons, and they're not that bad. They do build on each other, so please make sure you are not absent. Especially if you've seen it now, you missed class, but at least you're watching it now and you'll be able to understand the topic. Before I forget, the flashcards, the trig flashcards, are due tomorrow. Okay, and today's homework will be due on Wednesday, the 18th. Alrighty, so we're going to be using trig properties to simplify the given expressions. Okay, now the only thing that I want you to know, trig flashcards are due tomorrow. Something that I do need you to know are the following right here. So go ahead and write these down, pause the video, write these down on your notebook, do not lose them, and please, please, please study them. So pause the video, write them down. Okay, so pretty much what I need you to know is that there's these common ones. There are more, but for today's introduction, I only want you to be responsible for these 3 types. So the reciprocal, some of us have already seen it. We know the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Okay, now the same thing occurs. If I have cosecant, its reciprocal is sine. So same thing goes for secant, the reciprocal is cosine, and cotangent, the reciprocal is tangent. Oh, I'm sorry, cotangent, the reciprocal is 1 over tangent. Okay, so I know this looks a little bit intimidating, but from what you've learned already, you probably already know a lot of these right here. The next ones that I like to go ahead and make sure you guys really do know, because these, I don't want to say are more common, but these are often trick most students, but they aren't that bad. So remember, tangent, that is the same thing as saying opposite over my adjacent. And if I had to qualify the height of an opposite triangle, I would say y's, right? Y over x's, because my adjacent is normally the horizontal. So that refers to my y's are my sines. And what do you associate x's with? The adjacent side, the cosine side, right? So this is tangent. Whenever you see tangent, always try to change it to a sine over a cosine. When you see a cotangent, that is a reciprocal of tangent, as we can see here. This right here now is my adjacent over my opposite, also known as my x divided by my y, also known as cosine divided by sine. Now, what I want you to know is that, hey, I can go ahead and substitute any of these at any time because they are equivalent to each other. All of these statements are true, and we can go ahead and replace them as we see appropriate. Okay, last but not least, I really, really do enjoy the Pythagorean properties. So let's go ahead and see what this right here comes from. So keep in mind, all of these exist inside the unit circle. So when you see sine squared, cosine squared equals 1, that immediately should trigger some geometry or some algebra 2. I know last year, because of COVID, we kind of lost some instructional time, and so we tried to figure it out. But this should remind you of the equation of a circle. So x squared plus y squared equals radius squared. Or since we know we're in the unit circle, we can say x squared plus y squared is equal to 1 squared. Okay, so keep in mind that my sines is pretty much my y squared, my cosines are my x's squared, and my radius is 1, so 1 squared is still 1. So we have sine squared plus cosine squared equals 1. Now, keep in mind, we can find these other ones, but a lot of students prefer to memorize them. I'm going to show you it's not that hard. If you were to divide by sine squared theta or cosine squared theta, you would obtain these right here. So if I was to divide every single part by sine squared, I would go ahead and I would obtain this one right here. If I divide everything by sine squared theta. If I was to divide everything by, sorry, what did I say? Let's go ahead and do it before I say something wrong. Sorry, this would be by cosine, fudge. Cosine squared theta. Let's go ahead and do it, because even then you can see I forgot it too. But yes, if I see sine and I divide by sine squared theta, or u in this case, divided by sine squared u, sorry, and divided by sine squared u, we can see that sine over sine is 1, 1 plus cosine squared over sine squared, that is cotangent squared u, is equal to 1 over over sine, and 1 over sine, you can see 1 over sine is cosecant. Just keep in mind that is squared. So this one is division by sine squared u, right? Every single part. And that's how we obtain this. And ideally the same goes for tangent. I'm sorry, for division by cosine squared. Now here are some tips, guys. Now, what I need you to know is what we need to know is that make the life easier on yourself by changing everything to sine and cosines. Now, something that really helps us notice when there's a Pythagorean identity, which is the last ones we just saw, is these big triggers. Any trig, so sine squared theta, cosine squared theta, tangent squared theta, or any of the reciprocals. And of course, the one is always the big trigger. Always look at your notes, guys. You won't know when to substitute if you don't look at your notes. I mean, you won't know what exists, to be honest. Okay, and study, study, study. Okay, so let's go ahead and do some practice problems. So let me go ahead and hide my panels so I can have more space. Awesome. Okay. So what I want you to do is convert everything to sines and cosines. So go ahead and uh, substitute um, everything to sines and cosines. Okay. So go ahead and pause the video right here and give it a try. So we have tangent. Tangent. If I want to convert tangent to sine and cosines, as much as I want to go ahead and say, oh, tangent, that is 1 over cotangent. Sure, that is true, but I want to change it into sines and cosines, so I'm going to probably do something like this. Tangent is sine divided by cosine. So let me go ahead and substitute. Sine x, sorry about that, divided by cosine x. Okay, minus my secant. Let's go ahead and try it again. Secant, we can see right here, the reciprocal is 1 divided by cosine of x. Last but not least, cosine is already a cosine, so I'm not going to even mess with it. I'm just going to drop it down. That is cosine of x. Okay, this right here is my simplified version of this. Now, you're probably saying, like, what does that mean? I just changed them. Well, keep in mind, look, let's go ahead and see if we can combine more like terms. So if you notice these right here, when you are working with fractions, let's say 3/4 minus 1/4, we can go ahead and combine these fractions. The same thing goes here, guys. Even though this is trig functions, we can still do the same procedure, right? If we have the same denominators, we can convert it to one fraction. So same thing goes right here. The numerators, go ahead and subtract. We keep one denominator. Same thing as this example, right? Don't forget the cosine minus cosine. And of course, we can go ahead and manipulate this some more, but since we're just starting, let's go ahead and leave this here for now, okay? But of course, you can go ahead and mess with this cosine right here to make it simplified version where it has a denominator of cosine. Okay, let's go ahead and try the next one. So I'm gonna try to show you guys some more. So go ahead and try this one on your own. My students in class really not enjoy, but really has some concerns about when they can do and when they can't. But it all depends what we're trying to do. Right now, we're trying to simplify by converting to sines and cosines. And once we try to make a trigonometric proofs is when you get to use all your resources. So right now, just know what we can substitute. So we have cotangent. As much as a lot of students want to go ahead and do this, keep in mind, I want to change to sine and cosine right from the start. So by doing this, I'm going to actually create 2 extra steps that I don't think are necessary right now. So if we go ahead and go straight to cosine over sine, which is what cotangent is, cosine x divided by my sine x plus my sine of x, right? Because this is already a sine, plus my secant. What is my secant? Well, my secant is 1 over cosine. 1 over cosine. Okay, so this one was mostly in class to see the students were able to convert these. So hopefully this wasn't that bad. Unfortunately, I don't have common terms without having to multiply some more, but as of right now, this is what I would like to see from the paradox that I saw. Okay. All right. Now we're going to go ahead and start going to our Pythagorean identity. So keep in mind, sine squared plus cosine squared is equal to 1. So keep in mind, when you see this, guys, you can substitute back and forth. Okay. All right. So go ahead and give this one a try. Now, we have, hopefully you're able to see that, hey, this is not much different. So say, let's say x, sorry, let's go sines are y. So let's say y, x plus y. This would not be much different if this was an algebra question. This would be an xy plus a y squared. So a lot of students in class were getting a little bit confused and were like, well, I don't know how to do, I don't know how to start. But think about it, it was like an algebra question, guys. We would normally just distribute the outside to the insides, and if they're like terms, you square them. So that's what's going to happen. These are already in sines and cosines. So all I have to do is distribute. So it would be sine x times cosine x, And then if I distribute the cosine to this one right here, this would be sine x times sine x. Okay, now we're going to go ahead and see if I can combine any like terms. So sine squared and cosine squared are not like terms, so it's going to be sine of x times cosine of x. But sine times sine, those are indeed like terms. So that's going to give me a sine squared of x. So this right here would be my solution. Okay. Now, am I saying this is a more simplified version? Yes, I am. But in the terms of having this help us for our tricks proofs, is it easier to solve? Well, we'll see that depending on what angle they give us. Okay. So I like using x's, but keep in mind these could be thetas, betas, alphas, whatever the case may be. Normally I switch between x's and thetas. Okay. But it's up to you. As long as you're consistent, you'll be okay. Alrighty, so I want you to go ahead and try it again. Convert everything to sines and cosines and then distribute. So hopefully you're able to see that cosine stays as cosine. And then secant is 1 over cosine. So 1 divided by cosine of x minus cosine of x. Okay, cool. Now the next thing that we're going to go ahead and do is we're going to go ahead and distribute this cosine into each term. So it's going to be cosine times 1 over cosine. That's actually going to be cosine of x divided by cosine of x. Ooh, that's nice. And then cosine times cosine, well, we just saw that is cosine squared of x. Okay. So let's go ahead and continue. We have cosine divided by cosine. Once again, I was seeing my students on Paradeck. They were like, oh, well, I wasn't too sure what to do. But keep in mind, if this was, let's say, an x over an x, you would have totally told me that, hey, that's a 1. So there's nothing that should be stopping us from here. This is a 1 minus cosine squared of x. Okay. Now, even though I am happy we got this far, we can actually simplify this some more. Now, you're probably thinking, what the heck? How do I do that? Well, we have a 1. Okay, so that's a trig of Pythagorean identities. And we have a trig function, right? We have cosine that is also squared. So that are 2 triggers that I should be leaning to something like this. Okay, so even though it is true that all these will work, there's one that will help us with doing the least amount of work here. So I'm going to go ahead and look at all of these 3. So I'm going to call this one A, B, and C. And I want you to tell me, hey, which one of these will go ahead and give me so which one of these will match the best with this Pythagorean identities? Hopefully you were able to say that A, because I can see in A, I already have the cosine and I already have the 1. Now, is there a way I can make this cosine negatives to match what I already have? Well, if I get the cosine and if I was to move it to the right, we could probably make that happen. So let's go ahead and try it. So this is from our formula sheet, cosine squared theta, or x in our scenario, plus sine squared x equals 1. So if I move this, if I move this to the right, I get sine squared x is equal to 1 minus cosine squared x. Isn't that what we have here? 1 minus cosine squared, 1 minus cosine squared is equal to what? So our solution, squared x, is this right here. This is way more simplified than this right here. And that's the benefit, guys. We're able to evaluate sine squared x. Let's say, I don't know, let's say at pi over 3. This is way easier than simplifying this entire function at pi over 3. Do you get what I mean? That's why we're doing this. Okay, last but not least, I want you to go ahead and give this one a try. Use your notes, guys. So we have sine, and we have cotangent and tangent. So I'm most likely going to go ahead and simplify this the best I can. So I'm going to go ahead and convert everything to sines and cosines. I know cotangent is cosine of x divided by sine of x. And if you didn't know it by now, right here is the conversion. Okay, and then tangent is sine of x minus cosine of x. Okay, so we have all of this right here, and we can go ahead and distribute our sine. So if I distribute the sine into cotangent into cosine over sine, I get sine of x times cosine of x divided by sine of x minus, well, if we do the same thing with the other, we get sine x times sine x, which is sine x squared divided by cosine of x. Okay, so all I'm going to go ahead and do now is simplify some more. So sine and sine are like terms, they equal to 1. Cosine of x minus sine squared of x divided by cosine of x. So I want to go ahead and see how much more you guys can reduce it. There is two different approaches. Some students like to go ahead and see the sine squared and be like, oh snap, I'm going to go ahead and use the Pythagorean theorem. I'm sorry, Pythagorean identity. Other students were like, well, I'm going to go ahead and change this cosine to be cosine squared over cosine and simplify from there. Well, either way you do, guys, I'll accept both of them. It isn't until we continue learning this the rest of the week where we will actually want it to equal to a specific thing. So some of us will like to use the Pythagorean identity, which is fine, and some of us would rather multiply this cosine, which is cosine over 1, would like to multiply this cosine over cosine x, cosine x. Okay, so hopefully you're able to get to at least right here. And with practice, we're able to make the proper decisions, whether going this route or going this route right here. Um, did have some more practice problems here that we can go ahead and try out that include some very similar to what we did and some a little bit more different. And let's see where we end up. So if you do have more questions, please reach out to me and I'll gladly help you out the best that I can. As always, guys, it was a pleasure and thank you. Bye-bye.